All right, guys, we're on chapter 3. Can you believe it? All right, so phase changes lesson 3.1. So in this lesson, we're going to be doing parts 1 through 4. So let's go ahead and hop in and get started. So your warm up, you actually have a letter to read. So I hopped into Amplify so we can read that letter together. So this is the post that was left on the forum that needs your help to respond to. First, read it and consider any initial ideas on how to respond to it, and then complete the sim activity to gather more evidence below. Okay, so to us student chemists from Galileo, questions about lake evaporation. I read your findings about the lake, but I'm confused about the argument that the lake evaporated between 2007 and 2009. The evidence shows that Titan first started getting hotter in 2002 when summer began, but the methane lake was still liquid 5 years later in 2007. If the temperature increase started in 2002, then energy was being transferred into the lake. Why then hadn't it evaporated by 2007? So this forum user pointed out that the energy began being transferred into the lake as soon as summer started in 2002. Yet the lake still had not evaporated 5 years later when the probe first took the picture. Your mission is to investigate how much energy the substance can gain or lose before it changes its phase. Complete the steps below and test the possibility that energy was added without the lake changing phase. So you're going to use this simulation and make sure you click on substance B. You're going to transfer in as much energy as you can without changing the phase itself. So reset the sim when you're done and transfer out as much energy as you can without changing its phase to something new. Do all energy transfers lead to a phase change? Good question. How can you use this information from the sim to respond to this forum user? So you're responding to this forum's user's question. So pause the video here so that you can respond to the user's question in the activity number 1 part of the warm up. Okay, we're going to move on to activity 2, actively reading liquid oxygen. Now you guys actually have this article in your packet that is in your binder, so you can read it on paper. In chapter 2, you used evidence to develop the argument that the lake on Titan evaporated because energy was added to it when Titan's summer season began. Let's take a look at the time of Titan's summer to see if we can understand the forum user's questions. So, why is the forum user confused? If we look at this picture, why didn't the liquid methane change before 2007? According to this timeline, it had already been summer for 5 years. So, summer started in 2002 or just before 2002, and it had been for 5 years before the radar first photographed the lake on Titan. So, we got that first lake picture on Titan in 2007. The energy from the sun was transferring into the lake starting in 2002, but it took till 2009 for this lake to evaporate, which is a long time. So our question for chapter 3 is why didn't that liquid methane change phase before 2007? So let's discuss what we observed about energy and phase changes in the sim. So does adding or removing energy in the sim always result in a phase change? Did you try that? Does it always do that? Well, understanding that energy transfers don't always lead to a phase change raises new questions, such as whether energy transferring is enough to cause a phase change or whether the amount of energy varies between different substances. So, we're going to focus on this question today with this investigation. Why does an energy transfer not always result in a phase change? So, Dr. Flores thinks this article may be helpful in answering this question. It discusses how difficult it can be for some of these substances to change into a liquid. So I'm going to ask you to go ahead and pause here and read the article. Make sure you follow those reading guidelines. You should be annotating as you read your text and highlighting words that may be difficult to you or things that you think that would be important to help us answer this question or to help you as evidence for your future argument. So pause the video now so that you can complete that part. Okay, we're going to go on to discussing your annotations. So next, you're going to look over your annotations and choose some to discuss. Let's review the different hashtags that you'll use to select your annotations. So prepare to share. So you're going to find one of those annotations that you wrote that you are willing to share with your group. You'll put hashtag share on it. Then you're going to discuss the one that you chose with your partner and tag it with a hashtag discussed. If you were able to resolve your question, so you're just going to discuss it with your partner. And then step 3, prepare to talk to me about that when you go to wrap up your lesson and take your mastery check. So right now you can go ahead and start reviewing those annotations and discussing them with your partner, and you can pause the video here. So what connections did you make between the article and the sim? So in the article and the sim, what did you see happen? Well, sometimes the substances didn't change phase, even though energy was added or removed. Well, that's because kinetic energy was just not enough to overcome that attraction and make the molecules get pushed apart. So alternatively, the attraction wasn't strong enough to pull the molecules closer to each other either, so it didn't cause a phase change. So using the evidence from the reading of the sim, what did you learn about our question? So talk about that with your partner. You can pause the video here. Now remember, answering this question will help you respond to the forum user who wants to know why the lake on Titan didn't evaporate earlier. So we'll investigate these questions a little bit further in the next lesson. So review your annotations and answer the reflection question on the bottom of activity 3 in your lesson. Okay, pause the video here if you haven't finished up activity 3, and we will start activity 4 in just a moment. So in activity 4, you will be thinking about what you learned from the reading in the sim. Then you're going to revisit your first idea about phase changes. So when you hop into the lesson, it asks you to think about what you learned from the reading in the sim and record your initial response below. And don't worry about if you're not sure about the answer. You'll have time to investigate it further in the next question. So just honestly answer this question. Why does an energy transfer not always result in a phase change? So based on what you learned today, go ahead and answer that question. You can pause the video now. Okay, so we've reached the end of the lesson. Make sure you look on Canvas to see what you need to do for the next lesson that you are working on. Make sure you check your key concepts before you go take your mastery check, and ask for me to check over your lesson so that you can take that mastery check.